Okay, so you guys remember how proportional, I was telling you, if something like proportional and non-proportional, I said it's kind of one of the easiest things in 8th grade math because you're just looking at whether or not your b is 0. So functions are kind of the same thing. This one unit has 2 different standards that are actually pretty easy if you know the rule. Like, it's not even having to do any math with it. It's just whether or not you know the rule. I used to always teach it all together, but Mr. Walden told me that he actually just does 2 and 2. So I think I'm going to do the same today. Like, I'll do 2 of them today and 2 tomorrow. But the one rule that there is for a function, to make something a function. Okay, so it kind of folds funny. That's why I was folding it while you could see. You'll just have it look like that. And when you get a second or when you're ready, I want to write something in the journal that you'll have in there. Because I don't, look, I'm going to zoom out so I can show you. I'm going to put mine in here like that, not right now. So since I'm putting it like that, I'm going to write over on the left side. Okay, do you guys remember when I tried to make irrational numbers funny and I was telling you, like, if you got a girl or your man, they're being irrational and they just go on and on and on and they won't stop? Okay, so this is my funny to help you remember being a function. Okay, do you know what it means to be like a functional adult or a functional person? You're able to, like, take care of your own stuff, like you don't make dumb choices. Okay, so the one rule for function is that there are no repeating x values. So our funny way to be able to remember that is you don't go back to your x, right? What? Okay, so if you broke up with somebody, they're your ex for a reason, right? We shouldn't go back to our exes. So if you are a functional person, which means you are smart and you make good choices, we don't go back to our exes. So there's your funny way to remember. There are no repeating x values. Okay, so if you want to write, don't go back to your ex, that is fine. You guys can all point at your friends right now if you want to. Your friends that you know do this too much. Okay, so in tables and on graphs, and there are different ways to check whether something is a function, whether it's on a graph. Okay, thank you. I said point at them, I didn't say talk about it. If it's on a graph, we use one specific thing. If it's on a table, you can just look and see. If it's listed in order pairs, you can just look and see. But we are also going to look at something called a mapping diagram. And that's something that's new to y'all this year. But it's basically just a really weird way to write a table. Okay? So you guys have this written down on the left? Mm-hmm. All right. So let's slide over here. So today we are just going to look at graphs and this. You see how this says mapping diagram? So that's what a mapping diagram is. And we've got some spaces in there that we're going to look at it a little more in depth. But there are 2 different ways we look at it. So if we look at it on a graph, we're going to come up here first. And we use something called a vertical line test. What is a vertical line? Does it go left and right or up and down? Anybody know? It goes up and down. Okay, so if I draw a line like this is my vertical line. So on a graph, if I draw that vertical line and it intersects, what does intersect mean again? Do you remember? Like where it crosses something? if it intersects or crosses a graph at more than one place, then that would mean it's not a function. Because if a vertical line is straight up and down, look at this one here on 7. I'm going to show you one. If I drew that line right there, did my line touch more than one dot?
No.
Okay, what if I drew one right here? Did it touch more than one dot?
No.
What about here?
No.
Here?
No.
Okay, so that means this is a function. And now I'll explain that to you a little better. So this is my x-axis, right? So if I'm only having to touch these dots one time, that means this x is 2, 3, 4, -4. But if this is -4, 1, there's not any other numbers on -4, is there? So that's the same for each one. This doesn't repeat anywhere. Well, look at 8. If I draw vertical lines, look at my second one there. Did I touch a dot? My line touch more than one dot?
Yes.
Yeah, so that means here, this point is -2, -1. And this point is -2, 5. Okay, which one repeats there, my x or my y? Your x, so can that be a function? No, if you have a repeating x, it's not a function. And that's kind of all there is for that on graphs. You guys have any questions on that so far? If it's not touching? Just watch what you... Okay, let's look at number 9. This looks all squiggly and crazy. But if I want to see if this is a function, I'm going to use my vertical line test. Did I touch it more than one place anywhere here? Sorry, I'm going to try to zoom in on my squiggly some more. Did I touch that more than one place? Okay, what about here? Nope, just right there. If I went all the way across this graph, does it look like you're going to touch it in more than one spot? No. So this one is a function. It's good. What about number 10? If I drew a line here, I only touch once. What about here? 2 times. Almost everywhere on this graph, I'm going to touch it more than one time. So if it's got more than one, it's not a function. Do you guys have any questions on this so far? No? Okay, I hope not. I hope you understand it and we're not just quietly saying nothing. Okay, what about 11? Do you think that's a function? No, because look, if I draw my vertical line, I'm touching a lot. Like on this over here, I'm touching 1, 2, 3 different times. Hey, ladies. So that one's no. What about number 12? You think it is a function? I think so. It doesn't look like I'm touching anywhere more than once. Yeah, looks good to me. You just kind of got to check your vertical line test. So if you draw a line up and down and it touches more than one place, just like I wrote the points out on number 8, that has more than one x value. That's why we use that vertical line test. And the other piece we're going to look at today are mappings, okay? And they are these weird little circle things. Okay, and just a heads up for you. Every time you see these, X is on the left and Y is on the right. Okay? They never change that around. That's just how they roll. And I know it's really weird looking, and I told you it's basically just a weird version of a table. Okay? So the way you read these, what is 0 pointing to? 3. So that means that 0, 3 is one of my points. What about the 1? What's it pointing to?
7.
7. So that's one of my points. And the 2 points to
7.
7. And the 3 points to 5. Okay, what can I not have repeating?
7.
What numbers are those? We don't want to go back to our what? Your X's. Okay, so do I have any number that's there more than one time in my X's? I got 0, 1, 2, 3. Nothing repeats there, right? Do I really care that this 7 is there twice? No, because that's a Y value. Okay, so we're only looking at our X's. This is what is our important thing. Okay, so number 5 is a function. Okay, so you can look at it the same way with number 6. You can eventually, very likely, get to a point where you don't actually have to write your points out over here. I'm only writing them because this is new to us in 8th grade. So I want you to know what it means. Okay, so what would my first point be on number 6? -5, 1. Okay, what else do I have?
-3
-3
and 1.
and 1. And then I have 1, 2,
8.
8. That's not pointing very good, is it? Okay. What else do I have?
6 to 2.
6 to 2. Is that my last one? Who said no?
6 to 8.
There's also a 6 to 8 on there. So in this one, do I have any repeating X's? Yeah. So when you see it here, how many arrows are coming off that 6? 2. So when I said you don't always have to write all these out, you'll see that one number here has more than 1, 2, or 3, or however many arrows coming out. And that makes it not a function. Okay, so our only 2 like super easy ones for this unit are the proportional, non-proportional, and whether or not it's a function. Okay, so if you can remember, proportional relationships go through 0, 0, and to be functional, you can't go back to your X. Okay, that's my funny for today. Okay, do you guys have any questions? We're gonna start getting to practice. I'm gonna